Okay, so today we're going to be discussing rational equations. And rational equations, remember, have functions like f and g, but where f is on the top and g is on the bottom. And the goal of what we're trying to do is we're going to set it equal to 0, bring everything over to one side to do that, combine all the fractions into a single fraction, and then set the numerator to the numerator, which is the top, equal to 0. And what that allows us to do is find the values for which we plug in that gives us the rational function equal to 0. And the reason for that is because, for example, if we have 2 over 3, well, that's not 0, and the only way that a fraction will be 0 is if it's 0 over some number. Because remember, when you have any number on the bottom and 0 on the top, 0 divided by anything is equal to 0. So that is our goal. So first, let's do a relatively simple problem. And what we're going to do is we're going to bring over the equation, the expression on the right-hand side over to the left by subtracting it to both sides. So 1 over r minus 2 plus 1 over r squared minus 7r plus 10 minus 6 over r minus 2 is 0. So what that gives us, right, is a rational equation which is set equal to 0. And what we need to do in order to put all the fractions together is we need to have an LCD. So in order to do that, we need to factor this bottom part over here as 1 over r minus 5 times r minus 2. And then the other one stays the same. Okay. So the LCD here, I think, is pretty clear because the only thing in the bottom is this r minus 5 and the r minus 2. So what we have is going to be LCD of r minus 2 times r minus 5. The thing that's missing here is r minus 5. And then on the one on the right, the part that's missing is the r minus 5 as well. So let's go ahead and write all of that out. So what we get is r minus 5 divided by r minus 2 plus 1 divided by r minus 5 times r minus 2 minus 6 times r minus 5 divided by, r minus 2, r minus 5. And right over here, I forgot the r minus 5 because we had already multiplied top and bottom by r minus 5. So we have the LCD, right? The same common denominator. And we remember, when you're adding and subtracting fractions, you add the top or subtract the top and keep the bottom. So the denominator equal to 0, the denominator is the r minus 2 times r minus 5. The top, though, is r minus 5 plus 1. And then this right-hand side, don't forget, we need to use that minus 6 to give you minus 6r plus 30. And this is all equal to 0. If we simplify that top, this becomes minus 4 plus 30 is plus 26. And then negative 6r plus r is minus 5r. Is equal to 0. So once we have this, right, as written as a single fraction, we can set the top part, the numerator, equal to 0. So minus 5r plus 26 is equal to 0. And solving for this, minus 5r is equal to negative 26, or r is equal to 26 over 5. Now, there is one thing that you need to do when you're doing rational equations. That is, when you get to this end part, you need to go back and double check that your answer works. So you can do that by plugging in or simply by finding the restrictions of the domain. And we could have done that at this step over here. Because once we, oh, I'm sorry, one step below. Over here. Once we have it written in its factored form, the denominator, we can figure out where all those restrictions are. So right from here, can we see, I'll draw it out here, that R cannot be 5, and R cannot be 2 as well. So those are our restrictions. And since this value that we got at the end is not one of those two, it is an okay answer.
So let's bring everything over to one side. So subtract that entire thing to both sides. Now that we have that right-hand side equal to 0, factor everything that you can. So we get x plus 3. The denominator of that one can be written as x minus 8, x plus 2, x minus 14 on the top for the second one, and the factors for the bottom one is 8 and 4. And then lastly, this one is going to be x plus 4x minus 2. Plus 2. X plus 2. Okay, so let's find the LCD. So the LCD, you try to find each of the unique factors, right, in the denominator. So there's an x minus 8. There's also an x plus 2, and there's an x plus 4. These are all the unique factors in the denominator. Their highest power for each of these is 1. So the LCD is just the product of all three of these. So let's go ahead and see what each of them are missing. This first one over here is missing an x plus 4. So I need to multiply the top and the bottom by x plus 4. This one over here is missing an x plus 2. So I'm going to multiply the top and bottom by x plus 2. And then the last one is missing the x minus 8. So let's go ahead and write that all out. So this part over here is going to be x plus 4, x plus 3. The denominator is that entire multiplication. This one is going to be plus x minus 14, x plus 2, and then the denominator again is that entire multiplication. And then the last one, which is x plus 1 times x minus 8 divided by that same multiplication. And it's still equal to 0. Fraction rule says, again, same denominator, we can add a straight top and keep the bottom. So from here, we're going to add the top. So the first one plus the second one minus the third one. All divided by the denominator, which is x plus 4 times x plus 2 times x minus 8 is equal to 0. So here, can we see the restrictions is x cannot be negative 4, negative 2, or 8, because that'll make this bottom 0 down here. So don't forget we need that, it's important, and we'll see that later on. So in order to in order to solve this, remember, we just need to set the numerator equal to 0. So we set x plus 4 times x plus 3 plus x minus 14 times x plus 2 minus x plus 1 x minus 8 equals 0. That's how we find the roots. Now I get that this is a very big problem, but don't let the fact that the problem is really large distract you from what we're really doing, right? All we had to do so far was find the LCD set the top equal to 0. When you get to this part, what would you do? You would distribute it, simplify it as much as possible, and then see how you would solve it by possibly factoring or quadratic formula or many of the other ways that we had to solve these types of polynomials. So just do the distribution, do the arithmetic. So this is x squared. This one is going to be 4x plus 3x, which is going to be 7x, and then the last part is plus 12. Continuing on, x squared. This is minus 14 plus 2, so this is minus 12x minus 28. I'll keep the negative out there for now as x squared minus 7x minus 8 is 0. So here, the negative distributes so I can change all the signs. And now simplify. So those x squareds, the two of them cancel, and you're just left with a single x squared. The x's give you 14x minus 12x, so that's just 2x. And then the constant terms give you plus 20 minus 28, so minus 8. This is equal to 0. So all of this entire thing, turned out to be fairly nice, right? It's just x squared plus 2x minus 8. And we can solve that either by the quadratic formula or factoring. It is factorable. It's x plus 4 times x minus 2 is 0. Once you have factors equal to 0, again, set them each equal to 0. So here, x is negative 4, or x is equal to 2. So those are our two possible solutions. But if you actually look at this one right here is right there. So it cannot be a solution. This is no good. So the only solution is x equals 2.